All right, so good morning. And have you all received the news about the postponement of our bound? You should have expected that we will have a hard time this year. So sorry to tell you that the original date had to be postponed. Okay, has been postponed. So I can do nothing about that, but I would try our best to find a make-up date such that all of you would have a chance to enjoy it within your senior form study. This is my promise. As long as it's safe, I hope you guys can enjoy the Outbound experience. Any point, anything that you want to share with you here? Anyway, yeah, yeah, Phong Ka Him, yeah, bad news. I just shown it onto the web. Okay, so which means that in the 18th of January, with the coming 5 days, you have to continue your Zoom lesson. Okay. Anyway, we try to make up to find another date for you. Now, please double check for me who is absent today. And we've got 20. Oh, all of you, yeah. Yep. Don't mention too much, huh? Because it's not we cannot control actually. That is what we really cannot control. So today I would like to talk to you something more about the acid, the properties of acid, and later on we would come to the ideas about the alkali if time is allowed. Okay, you talk about that 2 topics. Okay, some more basic, but you need to get to know more about this. Now, to start with, I would like to give you a a video on 14.2. Now, this tomorrow we would have a quiz, as said before, as promised. So you'll have a quiz on doing the mocap. Again, so many different versions that you have to try your best to attempt. 知唔知道聽嘅測驗 ？OK， 馮家謙 ，you know。
Add half a spatula measure of dry solid citric acid to a dry watch glass. Dip a dry blue litmus paper into the solid acid. Record any colour change of the dry blue litmus paper. Add 1 centimetre cubed of water to the solid citric acid. Dip a dry blue litmus paper into the aqueous solution. Record any colour change of the dry blue litmus paper. Put a piece of magnesium ribbon into a dry test tube. Add 3 spatula measures of solid citric acid to the test tube. Record any observation occurred. Add water to the test tube to a depth of 3 centimetres. Shake the tube to dissolve the citric acid crystals. Quickly place the test tube upright in a test tube rack. Cover the mouth of the tube immediately with an inverted rubber stopper. Allow the test tube stand for 5 minutes. Record any observation occurred. Remove the stopper and quickly put a burning splint into the mouth of the tube. Record any observation occurred.
So after listening to this, so you may get to know more about that acid. What is it about? The reaction of acid with what? We have got some acids. I could with you citric acid, right? Now, citric acid, 檸檬酸, it is an organic acid, as said last time. So, in the lab, we would have it in solid form. Is in form of a powder. And maybe our experiment is to use the powder citric acid, the solid citric acid, to test its oxidative property. So, what do you know? What conclusion do you have? What conclusion do you have? Now, after watching the video about the solid citric acid, what are the chemical properties of citric acid? Are you here? Yeah. What are the chemical properties of citric acid if it is in solid state? It's soluble in water. Can you elaborate more on the chemical property? Chemical property of solid citric acid. Now, solubility is a physical property. Chemical property. Now, what experiment they perform to exhibit this chemical property? I put it with magnesium ribbon, right? I put it with solid sodium carbonate. So, what is the expected observation? You forgot? Now, wash it.
Corrosion.
Corrosion. Agree? Now, take a look on that again.
Solid citric acid to a dry watch glass.
Now, first of all,
dip a dry blue litmus paper into the solid acid.
Now, first of all, what is the conclusion? Huh? I use a blue litmus paper without moisten it, and I put it into solid citric acid. So what is the color change?
Record any colour change of the dry blue litmus paper.
Sorry, no color change. Isn't it an acid? Isn't it an acid, right? Citric acid is an acid. How come it doesn't exhibit acidic property? Can you get it? So citric acid, does it mean that the large molecule of an acid doesn't have the acidic property? Not really. Now take a look on what?
Add 1 centimetre cubed of water to the solid citric acid.
Now, this time I add water to it.
Dip a dry blue litmus paper into the aqueous solution. Record any colour change of the dry blue litmus paper.
Can you get what I mean? So it seems that, now, without water, the solid acid without water and water, they behave quite differently. Now, this is what I know is acidic property, right? I change it to red. Now, if I do the same thing and try to compare the action of solid citric acid and an aqueous solution of magnesium and try to see what will happen. Now, again, I do the same thing.
Put a piece of magnesium ribbon into a dry test tube. Add 3 spatula measures of solid citric acid to the test tube. Record any observation occurred.
Any observation?
No.
Just solid citric acid made from magnesium.
Add water to the test tube to a depth of 3 centimetres. Shake the tube to dissolve the citric acid crystals. Quickly place the test tube upright in a test tube rack. Cover the mouth of the tube immediately with a stopper.
And then
allow the test tube stand for 5 minutes.
They want to collect the
Observation occurred. Remove the stopper and quickly put a burning splint into the mouth of the tube. Record any observation occurred.
So you have got 2 experiments, right? One is the test it with the dry blue litmus paper, and the other one with putting into magnesium ribbon. And you are going to test the citric acid crystal. Is it in form of solid? And when you're going to compare it against the aqueous solution. Okay, we have got 2 cases and try to take a look on that. So what is the conclusion? Solid, when I put it into the dry blue litmus paper, no color change, but for aqueous solution, the color changes from blue to red. Okay, and for magnesium ribbon, for that one, no observable change. Okay, and this one, what will happen? Effervescence. And you are going to test it from the pop sound test that I know hydrogen gas is produced. And one more thing is about solid sodium carbonate. They would also have no reaction with solid citric acid, but for aqueous solution citric acid, they'll form colorless gas bubbles form, the carbon dioxide gas is formed. So what is the conclusion of these sentences? Water without water, right? They exhibit differently. In other words, water plays a very important role to make the acid exhibit its typical acidic property. Can you get the point? So the conclusion, all of you please mark down, the water must be present for an acid to exhibit its typical property. How do I know? Why do I know that it must be present? The best way to test it, to verify with the word must be, is to make it absent. Without water, no acidic property can be found, right? But with water, we've got that acidic property. Can you get the point? So the conclusion is that water must be present for an acid to exhibit its typical what property? Acidic property. So what is mean by that? 無水嘅酸咧就唔係酸咯。咁即係冇水嘅檸檬酸其實唔係酸咯，因為佢冇酸嘅特性。Can you get the point? Okay. So the question comes, why? Question comes, why? Now, when the citric acid crystals dissolve in water, what will happen? The citric acid molecules, they would ionize. Now, you be aware of the term to use is ionize. Ionize. Okay, ionize, which means that do not use the word dissociate, okay? Use ionize. Ionize means I want to have citric acid plus water. They will release to form a hydrogen ion and citrate ion. So we call that ionization. So what's mean by ionization? The molecules, they will turn to ions. Okay, so similar case, while I put it into HCl with the water, it's not a liquid, it's not solid, it's a gas. But we call it hydrogen chloride. Now, we don't have any hydrochloric acid gas. Instead, we have hydrogen chloride gas. Once it dissolves in water, the hydrogen chloride molecules, they will also ionize to produce hydrogen ions. So what does it mean by ionize? Now, it seems that we have got hydrogen chloride here. If I put it in the water, they will separate it. Okay, separate it, but not equally. The charge will not be equal. The negative charge will go to chlorine atom to form chloride ion. So you may find that we've got hydrogen ion and chloride ion inside hydrochloric acid. So similar case when you can have it for citric acid. We release it as hydrogen ion and citrate ion. And third case is about sulfuric acid. When the molecules of sulfuric acid and nitric acid, they will also ionize, okay, to produce hydrogen ions in water. So you may find that H2 SO4 are reacted with water to form hydrogen ions, and hydrogen ions. Leaving behind is sulfate ion and nitrate ion respectively. Can you get a point? So, which means that when I have, so what is the role of a water in this case? Water helps dissolve the acid, right? Point number one. And what is the another role? It provides the medium, right? Provide a medium to turn the molecules into ions. We call that ionization. Okay, to provide a medium for ionization also occur. Ionization for what? Ionization of acid molecules occur. Can you get the point? So that's why if you want to talk about acid, what is in common is that an acid is a compound in which they will produce hydrogen ions as only positive ions when dissolved in water. So with the word produces in here, we call it ionize, right? They ionize to give hydrogen ions as the only positive ions when dissolved in water. Can you get a point? How about without water? Without water, sorry, no ionization would occur. So no hydrogen ions. So of course, it not exhibits its accident property. Do you understand? So what is hydrogen ion? Hydrogen ion in water, it is not a just single ion. It's because of hydrogen ions being very small, okay, and but high charge. We've got +1 charge, no electrons already, only nucleus. So once I dissolve in water, so a hydrogen ion will be surrounded by water molecules to form a very special species. We call that hydroxonium ions or hydronium ion with the formula H3O+. So that's why we would use that two symbols interchangeably. One is H3O+, which means that you are going to tell it is aqueous hydrogen ions. They are of equal meaning. Can you get a point? But the fact is that hydrogen ions being very small, no electrons there, with a plus charge, will be easily attracted by the negative end of the water molecules. What I mean is the lone pair electrons of oxygen. They will have a what bond? Can you tell me? What is that bond? With an arrow here. Do you still remember what was that?
Covalent bond.
Yep, dative covalent bond to a hydrogen ion to form that species. We call hydronium ion or hydroxonium ion. Okay, so simply speaking, we will have to write that H plus or H3O plus interchangeably to represent hydrogen ions in aqueous solution. Is that clear? So what is the conclusion of the first part? Is that water plays a very important role and is an essential substance which make the acid exhibit acidic property. Do you understand? So we come to a class practice 14.2. Now, a student mixed a solid sodium carbonate with oxalic acid powder. He then add water to the mixture. What you expect to observe? Explain. Now this time I add water. So with or a originally solid oxalic acid at room temperature is formed a solid. Once I add water to it, what will happen? Observe. For example, explain. Second part. Observe. Effervescence, right? A colorless gas is given out. So here comes the reasons, explanation. So what will happen? Yes, water here, right? When water is added, so what will happen? Solid, the citric acid will dissolve, and then what? We use the word ionize, and then ionizes to produce what? Hydrogen ions. Okay? So the hydrogen ions, they are responsible for the typical property of an acid. So it will what? What does it mean by that? And so it reacts. So the hydrogen ions react with what? Solid sodium carbonate. Can you relate the term to the colorless gas? What is the colorless gas?
Carbon dioxide.
Yeah, to release, to give out carbon dioxide. So this is what you may know this. So remember, for that type of explanation part, you need to get addressed. So something very important is the term dissolve in water, and they are ionized to produce hydrogen ions, and because of that, they will exhibit the acidic property. This time, I react with sodium carbonate to release carbon dioxide. This is a sign of having the reaction. Can you get a point? What will happen for the case without water? Without water, so what happened to oxalic acid? It will not be ionized to form hydrogen ions. So no hydrogen ions, of course, they will not exhibit hydrogen acidic property, so they will not react with sodium carbonate to release carbon dioxide. So that's why no effervescence will occur. Can you get a point? You got it? Okay, so this is what you may know. Now, but the question comes, do you mean that acid is a hydrogen containing compound which one dissolve in water to release hydrogen ions, right? It's the only cation, as said before about the definition. The definition says it like this, right? A compound which produce hydrogen ions when dissolved, only positive ions when dissolved water. Do you mean that all hydrogen atom inside the acid molecule will be ionized? The answer is no. The answer is no. Now this one I can skip that, right? Ionic equation. I'm sure most of you have got it. We come to the word basicity. Basicity 鹽基度. So what is meant by basicity? The basicity is an acid is a maximum number of hydrogen ions that can be produced but in the one molecule of acid. So remember, we have got per one molecule of acid. Second, maximum number of hydrogen ions can be produced. So we will call that some hydrogen atom that can be ionized, or we will use the word ionizable to describe. For example, for hydrochloric acid, it is somewhat very simple. We have got HCl, so of course, for one acid molecule, we have got one hydrogen atom to be considered. Once it dissolves in water, it will fully ionize to form hydrogen ions and chloride ions. So you may find that one per acid molecule, here comes one hydrogen ion to be released. So we call that monobasic acid, or we call that basicity of an acid being one. Can you get the point? But for ethane acid, now this is commonly found in vinegar, right? 喺醋入邊揾到嘅乙酸. So you may find that the formula is rather complicated. C3COOH, right? So, however, while after careful examination of this substance, you may still find it as a monobasic acid. What's mean by that? Per acid molecule, only one hydrogen atom can be ionized. So we still call it as monobasic acid, but not the other three hydrogen. What do I mean by that? Is about that three. Now, why do we have only one hydrogen atom to be ionized? Does anyone know? But not the other three. 點解係淨係嗰粒咧？就明。
因為呢個我覺得呢個係嗰個COH 個 group 咯。個叫
The surrounding is yes is related to neighbor. Can you elaborate more on that? What is so special about this neighbor? The neighboring atom. Yes. Wow. Deng Junhei, we've got a very good, nice answer. We call it carboxyl group. What does it mean by carboxyl group? Deng Junhei, what is that? You know it in biology, is it? What does it mean by carboxyl group, Deng Junhei? Can you circle it here? What is mean by what is mean by carboxyl group? Yes, very good. COOH. Now, COOH here, it is called carboxyl group. So it is what we call that as a functional group, a reactive site. It is a place where it will exhibit its mainly chemical property. So for COOH here, why it would that O easily be formed as hydrogen ion is that O here being more electronegative. Okay, have you ever heard of this term, electronegativity? And H is rather electropositive. What's mean by that? Within that bond, we've got equal sharing of electrons, outermost sharing electrons theoretically, because of the likelihood of more likelihood of an oxygen atom to pull the outermost bonding electrons towards itself. It seems like tug of war, right? With a tie knot here, right? It seems like tug of war. We've got a strong people, we've got a weak people doing tug of war, and the tie knot will come near to the strong people instead. So I would like to put this remarks that it seems that electrons, the bonding electrons, is now being pushed near to the oxygen side. Can you get the point? So once I put in the water, what will happen? That bond will be easily broken down, okay, and that will easily form what? O minus and H plus as the only product. So we will call it a type of ionization, okay? So the bond to be cleaved is the hydroxy group. Here, they will break the bond like this. So that's why whenever I want to tell you the ionizable hydrogen ion, remember to check for what? COOH. If you see that cluster of atoms, that hydrogen inside should be ionizable, but not for the others. The other three hydrogen atoms, what I mean is that 3 is not ionizable. They are not ionizable. Can you get the point? Now, if you don't understand, I can give you some more different examples. For example, citric acid. I've just mentioned here, right? I'll write that formula. Could you please tell me what is the basicity of citric acid and oxalic acid, respectively?
Citric 係3，
Citric acid is 3. Why? Per acid molecule of citric acid, we have got 3 ionizable hydrogen atoms, right? Circle which 3? Which 3? Yeah. First, second. Yeah, that third. Why is it so strange, Mr. Chin? I will write it like this way. Okay? COH, right? The way of writing is just the opposite, right? So you are going to check for the connectivity of carbon, and it is indeed the connection is by carbon to carbon single bond. So I would love to write down as COH, especially on the leftmost molecule. I would like to write like this way. Okay, so that 3 hydrogen atom here, they are ionizable. So we call that it is what we call it as a tri-basic acid. Tri here means what? 3. Is that clear? How about oxalic acid? What's the basicity?
2，
Yes, that's 2. Because we've got 2 COOH group, well, that 2 hydrogen atom per atom molecule can be ionized. So basicity is 2, we'll call it as dibasic acid. Is that clear? Monobasic for 1, dibasic for 2, tribasic for 3. Is that clear? Okay. Questions? So what I just mentioned with you is on what? Is on the organic acid. How about mineral acid? The mineral acid is somewhat easy. Okay, so whenever you see the hydrogen atoms found inside acid molecules, all those can be ionized. So we will see H2SO4. We see the word 2 is dibasic. We see phosphoric acid. We got 3. We got a tribasic. It's just that simple. Can you get a point? So simply speaking, the whole case will be separated into 2 parts. For ethanoic acid, it is organic acid. Can you see that? This is somewhat very special. For organic acid, you are going to check what? Check the number of COH group, and you will know the basicity. Can you get a point? So the other case is that for the mineral acid, just check what? Check the number of hydrogen atom per molecule, and you would know the basicity. Do you understand? Do you understand? So we have got the two cases. Questions? Now, I'll give you this one. Circle it for me. Which hydrogen atoms are ionizable? What is that? We call that tartaric acid. Now we've got another acid, right? Tartaric acid is an organic acid. What is mean by tartaric acid? 走石酸. So where will you find the tartaric acid in nature? Do you know? Tartaric acid is commonly found in grapes. So we have got that 走石酸. So circle it for me. Where are the ionizable hydrogen atoms? 邓浩信, do you know where? One. Yep. Correct. 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 So what is the basicity of that tartaric acid? This one is correct. Now, so the way to check is simple. You're going to check for what? Carboxyl group, COOH, right? And that H is already the one which is ionizable. So we will call that basicity equal to dibasic acid. Questions? How about the other OH? The OH here, it's not carboxyl group. It belongs to another type of functional group, and you will know it in organic chemistry. Now this, what I mean by that is that these two is not carboxyl group. We call that hydroxy group. So if you find it, what is mean by that? It is a type of alcohol. So whenever you see it, it is alcohol. For example, CH3, CH2, OH. So what is that? Ethanol, use some. The alcohol commonly found in an alcoholic drink. So it is another family of organic chemistry, organic compound. You'll know it later, most probably in the late Form 4 to Form 5. Questions? Easy, difficult, or what? Oh, how many minutes do we have? I just put one double check.
We still have approximately 20 minutes.
Yep, thank you. So today we would not start the topic of base and alkali. We try to leave it later. So we would have a consolidation on acid here, first of all. Okay, we try to focus on acid. So we skip a little bit and go to page 25. Page 25. Now we mentioned something about the dilute acid, right? We come to somewhat more challenging. It's concentrated acid, right? Concentrated acid is more nasty, I must tell. In terms of safety, right? Concentrated acid. So the ordinary concentrated acid, they are usually set as corrosive. Can you see that? Corrosive. So the hazard warning labels should be noted. It will tell you the safety concern to you if you touch it. Okay, so whenever you touch that corn exit, you have to flush the affected area with running water for minutes. So, and ordinary concentrated hydrochloric acid, it will contains about this is some more factual you need to memorize. The 35% by mass of hydrogen chloride by mass, the concentrated acid sulfur acid, they will contains about even 98% sulfur acid by mass. So that's why you will say concentrated sulfur acid, you will use the word liquid. You will see that the symbol expresses liquid to tell it's concentrated sulfur acid, but not for concentrated hydrochloric acid. For HCl, AQ, it can be dilute or it can be concentrated. But once I write down H2SO4 liquid in the chemical equation, normally we are now referring to concentrated sulfur acid. How about nitric acid? Nitric acid is about 70% by mass. And among the three, I would like to draw attention to concentrated nitric acid. This is the concentrated acid which should be stored inside brown bottle. So underline the term brown bottle. Now, whenever you see the chemical which is stored in a brown bottle, which means that it's afraid of sunlight, okay? So it will be undergo photo decomposition so easily. So it would tend to decompose to brown nitrogen dioxide gas. It will speed up the decomposition under sunlight, okay? So it is put in brown bottle. Now, I give you about 1 minute. All of you, please search on the web. What is the chemical equations involved in the photo decomposition of concentrated nitric acid?
HNO3 turns into NO2 plus O2 H2O.
Oh, quite nice, right? Could you please write here such that all of you would get to know? Remember to balance the equation. Now remember to balance the equation to tell the photo decomposition. Now you will say that the decomposition under light, we call that photo decomposition. Okay, decompose under sunlight, so we call it photo. Any term we call it photo means light. What is that? Your handwriting is so nice, Lei Ching.
我而家喺電話度寫，好難。
Oh, it doesn't matter. You may read aloud about the chemical. What are those? NO2, O2, and H2O. You mean? Yep. NO2, correct. Thank you. So anyone who can tell the mole ratio, the stoichiometric coefficient of that, you balance that. Please balance that. 4, yeah, that's right. So I mark it here. Sorry to say that. I'll mark it here again. 4 for nitric acid. How about NO2? How many?
4.
4. O2 is 1. Okay, and H2O is 2. Okay. So this is the equation. Sometimes I would love to ask this type of questions. Then these concentrated acid has the characteristics of a typical acid. So normally speaking, they will react with a base to form salt and water as neutralization product. And but it's more than that. I must tell, it's more than that. So if you want to dilute the concentrated acid, this is what you may know in Form 1IS. Okay, you're going to pour the corn acid into water, but not the reverse. So remember, if you want to do the dilution, you add the concentrated acid slowly to a large amount of water. while stirring. So this is the key term. So could you please underline the whole thing? If you want to dilute the concentrated acid, remember to add the acid into a large amount of water with stirring. Can you get a point? Why? Because for the dilution process, it will generate lots of heat. Okay, especially during the places where the two chemicals meet. So it is a matter of the contact. Okay, the surface area of contact will help release the whole heat with that two cases. Okay, I can give you some analogy, such like having if I do it in reverse, right? Concentrated acid put into water, it seems like having a boiling water, large amount of boiling water, and I put a drop of oil, no response. But if you do it in reverse, what will happen? Heated oil, and I put it in the water. So what will happen? That water will splash, right, together with oil, so easily. So the case is very similar. So never dilute the concentrated acid by pouring water directly. If you add water to the concentrated acid directly, the heat will be released. It will cause the mixture violently splash out and then split into the face. Okay? So never attempt it like this. Okay? It's very dangerous. So that's why how would you do that? Especially for disposal of chemicals. Can you get the point? Finally, after usage of the acid, they do no longer not use it. So what should you do? You have to dilute it before disposal. Can you get the point? How? Pour the acid into water, large amount of water, but not the reverse. And this is it's not our habit, right? Very often I see people you wash a test tube, boiling tube like this. I open the water tap, okay, and let water flow inside directly into a glass container. Okay, so never do it like this when the chemical inside is concentrated acid. It will hurt you. Is that clear? Instead, you are going to pour the chemical out before you wash the the glassware inside. Well, what is worse still is about the corrosive nature of concentrated acid and alkali. Highly corrosive. It's highly corrosive. So, for consul, for example, is corrosive oxidizing. When I drop this into a piece of cloth, paper, what will happen? It will char. It will turn black. So carbon will be formed. Very highly terrible. Okay, why is it carbon? Indeed, the cloth itself is made of cotton. Cotton is a compound made up of carbon, hydrogen, and oxygen. So the concentrated acid plays a role by dehydrating the cotton. What does it mean by dehydrating? All of you please mark it down. Dehydrating. Dehydrating means what? They pull away the water from the chemical. But indeed, it's not just drying. Anhydrous calcium water is just drying. But dehydrating means something, a chemical change. It is ability to pull away those and make it as water. And leaving behind is carbon. So it is a chemical change. Dehydrating agent. Please mark it down. Concentrated H2SO4 is a dehydrating agent. So once you handle this chemical, be aware of it. Okay, is that clear? And what else? What else? Yeah. And well, some concepts that are quite scattered here. So that's why we sometimes will use concentrated sulfuric acid as a chemical to absorb water vapor. Okay, to dry something, to dry the gas, for example. So why if you watch it. We've got a concentrated sulfur acid. If I leave it in air uncovered for some time, the water level here will rise. Okay, have risen a bit. So we would call this type of a chemical hygroscopic. Hygroscopic. So what is mean by hygroscopic? Cups up. So of course, that type of chemical is rather effective to dry the water vapor in the air. When you compare with, but it's not safe. But it's not safe. Which one is safer? What are the drying agent that you use it commonly, which is rather safe to you?
Silicon.
Silicon.
Silica gel.
Yes, not silicon and silica gel is two different things. Silica gel. It's not silicon. Silicon is just the element, right? Silica gel. What is the compound found inside silica gel? Now, please search in the web. Silica gel. What is that? So silica gel is a safer choice, right, in our daily life. But of course, in the chemistry lab, sometimes we look for efficiency, so we use concentrated sulfur acid instead. So I would use the following substances as a drying agent. Okay, Consul, silica gel, anhydrous calcium chloride. Now, except before in rusting, calcium oxide is also a choice, right? But it will release some heat, right, while we absorb certain amounts of water vapor in a very short time. Okay, and one more term that you may know is the term data question. So what does it mean by that? Data question, it means they will absorb the water vapor until it forms something liquidly, watery in a solution. So we call that deliquescent. OK， 叫做潮解，即係吸濕吸到變成水啊！咁we call it deliquescent. OK, so that is what you know is in Consul. So you may, if you are going to dry the gas using Consul, you use this setup. Please memorize this setup. If you dry the gas using anhydrous calcium chloride, the calcium oxide is solid, you may either use U-tip or with the tip with a full packed column of the drying agent like this. We've got the two cases on the book. Okay, and we would sometimes use but remember, not all gases can be dried using this. For example, concentrated sulfur acid and anhydrous calcium chloride cannot be used to dry ammonia gas because there is a chemical reaction. Ammonia gas is somewhat alkaline. It's an alkaline gas, while Consul is acidic, so it will react. Okay. So similarly, if you think of calcium oxide, okay, somewhat it is a basic one, basic substances. So you can never dry acidic gas because of a similar philosophy. Okay, just like carbon dioxide and sulfur dioxide. What does it mean by that? There is a chemical reaction. Okay, so this is what I would like to draw attention to it. So for the places where you would keep the whole thing with dry, we call it is desiccator, 乾燥器. So it is a glass container. Okay, and I need put the drying agent at the bottom, and I put the chemical, which is rather hygroscopic and even deliquescent, inside, to keep it away from the moisture. Can you get a point? Okay, so this is what you may know about Consul, concentrated sulfur acid. We've got these cases. Now, take a look on that two setup. Something is wrong. Can you make it correct? How about the setup one? Why is it wrong?
佢左邊嗰支管應該要塞入去咯，右邊嗰支就應該即係
咩叫塞入去？
掂到嗰啲 exit 咯。
哦，掂到 just touch。
唔係喺入面咯，即係
咩叫喺入邊啊 ？Can you say that in English?
For the one with the HCl, the tube where the HCl enters the concentrated sulfuric acid has to be inserted in under the surface of the liquid.
Oh, insert under the surface, or we call it immerse, right? Put it inside, and then
the one which the gas is out, dry gas is outputted, should not be touching the acid.
yes, for the outlet, the delivery tube should be put it above. But if I do it in reverse, what will happen? First of all, the wet gas cannot be dry, right? But at the same time, because of the pressure difference, what will happen? The concentrated sulfuric acid will leave instead. Can you get a point? So this is somewhat problematic. Can you get a point? So this is the reason. First of all, the moist gas cannot be dry. And second, the concentrated sulfuric acid instead will leave. So it is dangerous. Can you get a point? So this is because of the pressure. So you're going to push the concentrated sulfuric acid through the tube outside. How about the second case? What should be corrected? If I insist of try a sample of HCl, is it a good choice?
will reaction, a chemical reaction.
Yeah, there is a chemical reaction. Calcium oxide react with HCl to form what?
Calcium chloride.
Yep, and
water.
Yep, water, good. So what should be replaced? Calcium oxide should be replaced with
anhydrous calcium chloride.
Yep, better choice, because it doesn't react with the HCl gas, which is liquid. Can you get it? Okay. Now, so in this lesson, we come to something more about acid. So what do you know about acid? First of all, acid without water would not exhibit the acidic property. Point number one. Point number two, with water, what will happen? It will ionize, okay, to produce hydrogen ions. While hydrogen ions is the chemical response, but is found in common in acid, which exhibit this acidic property. Without water, no such ionization will occur. But not all acid molecules will have all hydrogen ions ionizable, hydrogen atoms ionizable. So you are going to check for what group? COOH, right? Whenever you see COOH, that H should be ionized, can be ionized, right? And what's next? We come to corn acid. Corn acid is somewhat corrosive, okay? And you need to handle this with care. One point I didn't mention is about the oxidizing property. So you will know it in red dots later. So what is meant by that? Even for less reactive metals, just like copper, just like silver, can also react. So we call it oxidizing. So I would like to have a coverage of that in red dots. But be aware of the safety issues in dilution. Okay, you're going to add the acid into water, and be aware of the corrosive nature of it, especially concentrated sulfuric acid, being a dehydrating agent, to draw away the element of water to char the material. try to think of it as a finger, right? The skin, that will be problematic. And the uses of that concentrated sulfuric acid, because it can draw away some water, so it can be used as a drying agent, together with some other cases. Okay, so this is what we just mentioned it. A very fruitful lesson for you. Any questions so far? Now, if you have no questions for that, I would like to stop it here, and we will continue on the word base. Okay, in the next lesson.
Teacher,
Yes.
我想問 hygroscopic 同埋 deliquescent 有咩分別啊？
Now, I would like to have dismissed some other students first of all. Okay, for the others, you may have a recess. 咁hygroscopic 啊 deliquescent 其實就係講緊吸濕啊。hygroscopic 咧，佢嗰個吸濕咧就係佢係吸完濕之後咧，譬如話佢就咁講吸濕嘅啫。譬如話我哋講 Corrosive 吸濕，我睇緊嘅就係咦佢可能做咗dilution啊。但係 deliquescent 咧，佢嗰隻吸濕咧係吸到咧誇張到係咩咧？首先係講固體，跟住點啊？一吸濕咧吸到係佢變水狀。嗱，其實咧我哋啲化學實驗室咧有啲 chemical 咧都會咁嘅，即係會放得太耐咧，咁佢有水氣咧，佢就會除咗吸濕之外咧，佢一吸濕咧第一個步驟係咩咧？會越嚟越黐立立嘅 ，OK？ 咁黐立立到一個位咧，開始變水狀啦，咁即係佢淨吸到咧變成一個 solution 啦。咁我話咧呢個叫 deliquescent 咯，得唔得？所以咧，如果你講緊 solid sodium hydroxide， 佢話 deliquescent substance 咧，佢嘅意思係咩咧？佢吸濕，佢唔係黐立立咁簡單，仲要係變成水狀咁嘅狀態，叫 deliquescent 咯，得唔得？鄧會長明唔明？
好 ，OK，好唔該。
OK，好，so much for that。Okay, see you guys. Bye bye.